Hey folks, today we're going to look at area of, what are we doing here? Let's do rectangles and triangles. Alright, the first thing we need to discuss is what is area? What does that even mean? Well, area, to give you an easy definition, is the amount of space something covers. So the simplest way to kind of explain it would be, let's say you had your bedroom, and you wanted to know. So here's like a top view blueprint of your bedroom, and here's like the door and stuff, and maybe here's your bed, okay, and then you got some, like, I don't know, probably like big screen TV or like a projector over here and blah blah blah. Alright, so let's say you wanted to know, you said, Mom, Dad, I'm tired of this carpet, I want some ceramic tile. So let's say you wanted to tile your bedroom. So you're going to need to know how much tile to buy. Well, the area of your bedroom, in other words, the amount of space that the flooring takes up, that is area. So you would need to know the dimensions of your room so that you would be able to buy the right amount of ceramic tiles so that you could tile it. So it's a very simple calculation with rectangles. You essentially measure the vertical distance, or the sort of the up and down, and you measure the horizontal distance. So you would measure this side, assuming your bedroom looks like this and it's a nice rectangle or almost a square, and you would take this number and whatever this measurement is, and essentially you would just measure the wall. So from this corner to this corner, and then this corner to this corner, and what you do is you multiply them together, and that will tell you how many tiles you would need to cover the entire floor in your bedroom. Okay, so it looks something like this. So how many of these are the tiles that you need to buy. So that's kind of what area is. How much space something takes up, or what it would take to completely cover, in this case, the floor. Okay, so for rectangles and triangles, the calculation is very simple, very straightforward. Let's take a look at some rectangles here. So let's say I've got a rectangle that looks something like this, and let's say I've got a little skinny one that looks like this, and the measurements are, we'll say, 5 meters by 3 meters, and this one is 2 meters by 8 meters. So the simplest shape to find the area of is any rectangle or square or anything that has nice straight edges meeting at 90 degrees in each corner. All we're going to do is the formula for those. So I write area of, I'm going to put a little rectangle here, is simply the length times the width. Okay? Now, here's where kids mess up, and I notice this all the time. You get kind of hung up on, well, which one is the length? Is this one the length, or is this one the length? Or looking down here, is this one the width, or is the width this? It doesn't matter, okay? As long as you're multiplying the vertical measurement by the horizontal measurement of whatever shape we're dealing with, you're going to get the answer. So here, our answer is going to be 5 times 3, which gives us 15. Down here, we're going to have the vertical by the horizontal, say, and we get 16. Now, area has its own unit for measurement, okay? This is meters. It's a straight measurement. This is meters. Same with here and here. Now, when we get our answer, what do we put? What goes in this spot for the units? Well, the easiest way to put it is because we multiplied two numbers, in this case 5 and 3, in this case 8 and 2, and they were both meters, 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 meters. We essentially took a meter and multiplied it by itself. So our units for area are going to be meters, because we're dealing with measurement, but because we times two of them by themselves, meters times meters, we actually throw on a little tiny 2 here. And this means that the area of these rectangles are 15 meters squared and 16 meters squared. Okay? If you don't put this little 2, you're not telling anyone that you know what you're doing or that it's area that you're dealing with. So you need to make sure that you put this little tiny 2 that's kind of raised above. Okay? It's like this is an exponent essentially. Okay, so the area of this, 5 times 3, 15 meters squared. The area of this, 2 times 8, 16 meters squared. And that's how you do the area of rectangles. Now, sometimes we deal with shapes called parallelograms, okay? And a parallelogram looks something like this. And let's say we wanted to find the area of this shape. What is the area? A little bit trickier to see and decide because we're not dealing with we're dealing with a horizontal line, but our vertical line here is slanted. It's on an angle. So which measurement are we going to use? So let's say I had this labeled, and I said this was 10 meters, and this was 3 meters. The area of this is not going to be 10 times 3. And the reason it's not going to be this 3 is because this 3 is not a perfectly vertical line. It's on an angle. So what we need to do, and the questions will always give this to you, they'll give you this measurement sort of within the parallelogram. Okay? And this measurement is going to meet the horizontal, in this case the horizontal side, at 90 degrees. Okay, so if this measurement was, say, let's say, I don't know, 2.5 meters. So if you had this question and I said, what's the area of this parallelogram? This 3 right here is actually an evil decoy. Okay, I'm going to draw a little evil face. We don't even care about it. All we care about in area is the perfectly horizontal measurement, which in this case would be 10, times the perfectly vertical measurement, in this case 2.5. So they meet at 90 degrees. This 3, we don't like it. We're not going to use it to find the area. So the area of this parallelogram is, in fact, area of this parallelogram is going to be 10 times 2.5, which gives us 25. Now our units will be meters squared, and that's how we find it. Okay? The reason we don't include this 3 is because this measurement does not intersect with the horizontal measurement here at 90 degrees. Okay? And you'll always be given this spot. Okay, this 2.5 here, you're always going to be given it because it's going to meet the horizontal measurement at 90 degrees. So the vertical is 2.5 times 10, 10 times 2.5, the order doesn't matter, 25 meters squared. Okay, let me show you a quick proof of that. So why does that work? So here I've got a parallelogram. Okay, I'm just going to draw this. Now let's say I'm given this measurement here. Okay, so let's say I know the horizontal measurement, and I know this vertical measurement. And let's just, for example purposes here, let's say this is 12 centimeters and this is 3 centimeters. Now, what you can see here is I've got this little triangle, okay? It's not necessarily labeled, but there is a triangle here, okay? If I were to cut this off and shift it over, so this blue triangle, and place it here at the other end of the parallelogram, what I've now created is a rectangle. Okay, so I got rid of it from here, I cut it off, and I moved it over here. So now I have this rectangle, and I've attached that piece there. So now I have this green rectangle. Well, how do we find the area of a rectangle? It's the horizontal measurement by the vertical measurement. So this green rectangle here, as we can see, is simply 3 by 12. So originally it was a parallelogram, but when I cut this piece off and moved it over here, I've now created this green, and they take up the same amount of space. If I put this blue piece back here into our original drawing, okay, original drawing was a parallelogram, just by cutting a piece off and attaching it to the other side doesn't change the area. I still have the same amount of stuff, right? So our area here is going to be, the area of this rectangle is 3 times 12, which gives us 36 centimeters squared. Okay? So that's how parallelograms work. They're the same as rectangles. You just need to make sure that you don't use any of the slanted sides measurements in the formula. Okay? We didn't use it here. We didn't use 3. And over here I showed you the proof of why it works. You can take this piece, put it over here, and you create a normal rectangle with perpendicular sides from the original that had slanted sides, which gives us 36 centimeters squared. Okay? So that's how we do the area of rectangles and parallelograms.